Hi, it's Jan Beta. Happy New Year. Today we're going to build an open source, open hardware, all mechanical replacement for this thing, which is the Atari 8-bit XE series keyboard. The original keyboards for the Atari XE series of machines are legendarily a bit mushy to type on, and also they rely on a pretty brittle keyboard membrane, which often breaks and renders the keyboards unusable, basically. There are new membranes available and you can fix these pretty nicely, but they're still not very good keyboards. Also, what always bugged me is the positioning of some of the keys, especially the caps key, which I always hit when I really want to hit return. And actually there is a solution to all of these problems that is super nice, takes the Atari XE keyboard to the modern times kind of. And that solution is the DecentXE keyboard that was developed by some members of the AtariAge forums. The whole project was started by Bertrand, who goes by the nickname Screaming at the Radio in the AtariAge forum. And then several members of the AtariAge forums gave feedback and helped with making this thing happen, including Jesse, who actually started the process of bringing one of these to me to take a look at. So huge thanks to everybody who contributed, especially to Jesse and Bertrand, of course, who kindly sent me not one, but two kits to build these new keyboards for the Atari XE. And as usual, there are links in the video description for this video to everything I show you here. These things are fully open source, open hardware. Everything you need to build them is linked in a GitHub. There are very concise instructions on how to build these. I'm just going to walk you through the process while doing it myself. This is of course the first time I attempt this, because this is the first time I have one of these in my hands. Yeah, we're going to see how it goes basically. This is going to involve a lot of soldering. Thankfully not quite as much soldering as for the Amiga project I did, the Amiga keyboard I built with the mechanical key switches. We don't have to populate the resistors for each individual key on this one because they are surface mount and come pre-populated by the PCB manufacturer, which many PCB manufacturing houses offer as a service. And also this flat flex connector is populated, and maybe you have spotted it already, this thing comes with LED backlighting, which is pretty modern for an Atari 8-bit computer, but I think it's also very cool because we kind of got used to it in recent times, and it's going to help me use my Atari 8-bit in the dark, just as I like it. This is probably a good opportunity to thank the sponsor for this video, PCBWay, my favorite manufacturer of PCBs of all kinds. They also do 3D printing, CNC machining, sheet metal fabrication, basically everything you need for this project and other projects. They are able to make that happen. Their pricing is super reasonable, the quality is very good, so I highly recommend checking out the link in the video description. Back to our keyboard build. The whole project started as an attempt to make this keyboard a mechanical keyboard, basically. It used the original keycaps and just added adapters and a custom PCB and mechanical switches to transform this into a better keyboard, because it is quite nasty to type on. Mine is especially yellow, so I'm not very fond of this one, but yeah, even when these were new, they were not the best keyboards around, I guess. Yeah, the project kind of evolved into what it is today. It saw several iterations, and this is kind of probably one of the final stages. There was a lot of feedback and a lot of changes, and now this is what we got. So with this PCB you can use the old keycaps still with some 3D printed adapters. I'm not going to look very deeply into that. I'm just going to briefly mention that in passing here. You can 3D print adapters to go on modern switches and then use the original keycaps with this PCB, but what Bertrand and Jesse sent me is actually a full set to make a completely new keyboard with new keycaps printed by WASD. These are really high quality custom printable keycaps. We are going to use brown Kale, I believe, switches. But you can use several different types of switches in these PCBs. There are cutouts for many different manufacturers and MX compatible keycaps. Beautiful things like that. So you can customize this to the switches you prefer. Yeah, this is a PCB with the surface mount components already populated. The Gerber files for this are available in the GitHub. This actually is a plate that is an aluminum plate, which many PCB manufacturing houses also offer as a service. The first iterations of this used a steel plate, I think, that was cut, laser cut steel plate, but that didn't really work out because that was a rusty and bendy business. So aluminum is the way to go, it seems. Yeah, this goes on here and holds the whole thing stable. The kit also comes with these optional parts, which are, I think, just to hold the keyboard in place when it's assembled, so it doesn't slide around in the Atari case too much. Yeah, this is the GitHub page for the project, and it is very concise indeed. It goes through the history of the whole project, and then it mentions some of the iterations with different flat flexes and things like that. Some videos about the process are also linked here. Schematics, we have the bill of materials, and we have instructions on how to make these special keys, which have, of course, you can't use standard keycaps for those because they have a special shape. And you have to 3D print them, or you can use the original ones from the original keyboard. Yeah, I guess it's pretty pointless to just show the instructions on screen. I'm going to build this and show you the steps that I'm taking, and I am going to report every issue that I encounter on the way. So maybe this video makes it easier for you to assemble this thing if you plan to do the same. One quick aside, in the GitHub it says that these keyboards can be bought from Bertrand as kits or fully assembled, but it's strongly recommended to just order the parts yourself. It shouldn't be that difficult to source the components, and if you are good with the soldering iron, the soldering part shouldn't be that much of an issue. The more complicated stuff is getting the 3D printed parts right, but there are instructions in the GitHub on how to do that or where to order them as well. So it should be relatively easy to source the parts if you really want to have one of these keyboards. And if you can't, for some reason, you can still ask in the AtariAge forums. I made the experience that whenever I make a video about one of these smaller hobbyist projects, they kind of blow up and many people want them at the point they see the video. So if you order one from Bertrand, be nice, be patient. This is a very small scale hobbyist project basically. There's probably going to be a lot of direct messages that Bertrand gets. I don't want to toot my horn too much, but there's probably a couple of thousand people watching this video, and if a couple of hundred of them want one of these keyboards, it's going to be a lot more than usual in the peaceful AtariAge forums, I guess. With that out of the way, let's start building this thing. So for the modern keyboard variant with the new keycaps, we actually need Durock version 2 stabilizers. And we need them on the backspace or delete key, the spacebar, the return key, and the left shift. So these are the ones that we need to populate, and there's these little doodads that we have to put together. So we have these bracket parts that have some screw holes in them, threaded inserts, and this is how these look when they are assembled actually. Smaller parts that go into the larger parts, like these. These slide into here from the bottom, I think. Yeah, these sit in here like so, and then we have these rods that go in these holes through the little things that form the stabilizer. This is clearly the one for the spacebar. That's how these come together. This is the orientation. These little things go in here. There's a little plastic piece inside there that goes up, and the part that's facing diagonally upwards is the part that is facing the threaded insert here. The metal rod goes into the other end of it, like so. Yeah, and the way you insert these into the circuit board is by pushing the non-threaded part in and then pushing the part with the screw in. Getting one of these little washers over the screw and then screw it in. Let's see if my screwdriver is small enough. Yeah, it is. Yeah, and that is in. So yeah, and we are going to do this for all the stabilizers. You slide the part that doesn't have the threaded insert into the larger hole here. Then you push the other end into the place on the circuit board where it actually fits. And then you screw it in from the other side of the PCB. Probably all of you who have ever assembled a modern keyboard with these same parts are laughing at me at this point. But I have no experience whatsoever with these little things. This is the difficult bit for me, assembling small mechanical things. Okay, this was the first step. That's the stabilizers. Next step is configure the keyboard for the modern layout. There's actually jumpers here to configure this to one of the pinouts because they changed the layout slightly. We are going to have a larger return key, like a modern larger return key that goes in place of the return key and the caps lock key on the original keyboard. So you have to kind of modify the pinout a tiny little bit to make the modern layout work, and that's what these jumpers here are for. So for the configuration we are building, we need to solder the two jumpers labeled modern. And for the vintage, you need to solder this one and this one. And that just is for the caps and the control keys that are in different positions in the layouts, the original layout and the modern layout. I'm just using some leftover wire from my parts bin here. There we go. Two jumper wires in place. And these are my two jumper wires. And now we need the aluminum or aluminium plate here. So we now insert all the switches from the top into this with the LED window to the front, which is this part here with the opening, and with the pins to the bottom or back. So these should clip in here. Yeah, they do. So these all go into this just by clipping them in. So for the delete thing, we need to clip this in the center position for this keyboard layout. That's one specialty. For the older keyboards, I think this is wider. And the same goes for the return. That also goes into the center position, I think. This is going in sideways with the pins facing left. Okay, I'm just going to populate all of these. We need to populate the shift key in the center there as well. And then we have to fit this into the circuit board at some point, I think. These are the regular height keycaps. If you ordered all the parts, you should have some low profile keycaps as well for the function keys. But this is only the part for the main keyboard assembly. Oh, the instructions actually say for these center position switches, these three, you may want to insert the switches later when the plate is already on the PCB to make it easier to position these. I didn't read that. Now I read it. So I'm probably going to have to remove them again and then place them once this is on the keyboard PCB. But the other ones, there should be no problem. They all just stay in place pretty nicely. So I got all my switches in place. I think now it's time to check for bent pins, which I already see 1, 2, 3. Now we bring the two parts together. There we go. Okay, I think the two parts are together. It wasn't as bad as I thought, and I didn't have to remove the sliding parts here. Now it recommends to put this together with some clothespins or something the like. I have some clamps here I think I can use, just so it doesn't move. The plate and the PCB should be a few millimeters apart, more or less evenly spaced across the whole surface. Let's check. Looks pretty good to me. Yep, no wiggle room. Okay, time to solder in all the regular height switches. We are going to have a separate 3D printed plate for the switches that go on top here, the odd shaped ones, but the instructions say to do those later. So we're going to stick with the instructions there. And I'm just going to solder some strategic ones so this holds in place first, I guess. Just to make sure everything stays in place, in the correct place. And then we can remove the clamps and solder the rest. So now this should be stable enough. Soldered some on the sides. And it's still very straight. That's good. Okay, now for soldering all these little solder joints here. There's only 2 for each key, of course, but yeah, still quite a few in total. Yeah, that should be that. So now we do pretty much the same for these 5 switches here, but we use low profile switches, preferably of the same type. But you can of course use whatever you want, whatever fits. There's a 3D printed bezel for that, not an aluminum plate. And they also have a cutout on top for the LED and the pins on the bottom. And these go in here. So these are going to be soldered in, of course, as well. After double checking they're all nicely in place. Yeah, looking good. And the pins are not protruding, but that's not going to be much of an issue there. And on these 3D printed parts, there are little cutouts to make room for the components on the board. So this is the way you want to do it. The side without the little cutouts is on top. And you can probably see these little indentations here to make room for the surface mount components there. And these are going to be soldered in now. So, got my multimeter in continuity testing mode. These should all be connected together. Yeah, that definitely works. Yep, all our keys work. Nice. Or at least the special keys that work. Yeah, that's pretty much all the soldering we have to do, I think. We're going to insert the little flexible PCB that it is, which will act as the keyboard cable connector to the actual Atari. This flexible PCB, which is pretty neat. It's a bit thicker on the edges, so it's easier to insert. And this goes into this connector here from the bottom side. So these connectors have a little clip here that you can push forward in this case. Oh, the contacts directory is supposed to face the bottom of the board, so like so. Not sure how this is supposed to work. So you have to bend this quite a bit around and then insert it. That is a very strange move. I'm not sure if I can pull this off. How am I supposed to do this? So you have to fold it like this to get it in there, but I'm not sure if I can. Ha! I think I have it. So you bend it pretty tough there. And then you can kind of pull it in. And then lock the connector here in place. Yeah, that should be in. Okay, so I hope the flexible PCB is flexible enough for this stunt. So in theory we should be able to connect this end to the Atari connector and test the keyboard. So here's my Atari 65XE board that I tried to mod to be a 320XE without much success. But this should plug in here and we can at least test it before I take another look at the Atari at some point. But yeah, this should now be connected to the Atari itself and we should be able to see if it works. Oh, and it's blue LEDs all the way. Yeah, there's our self-test. There's a white power LED and blue LEDs for all the keys. Nice. So this is what it looks like. We have lit keys. All the keys are lit, even the ones that are not populated. These are just going to be hidden by the case. This is the power LED. It's a white LED. I guess you could choose the LED colors as well. Okay, we have already determined that the LED backlighting works, which is pretty nice, and we have determined that our option key, which is this one, works. So let's see if the other keys work. Select should be this one. Yeah, that works beautifully, and we should be able to push start. That's the keyboard test. And it crashed. We have something shorting out here. Something is like always activated. Something is not right. So I'm going to check for shorts, I guess. So I think I found one short that I caused by my messy soldering on the brake key here. This is pretty difficult to get these two solder pads apart. These are not connected actually. This is for another switch thing, and if you short this portion of an MX compatible switch to this, the switch is always closed because this whole via is connected to the other side of the switch. But now these are no longer connected after scratching away a bit of a solder blob there. I think that was the trouble. The brake key was just always actuated. Nope, that wasn't the only problem. So yeah, I'm just going to look for more shorts. The keyboard should work in theory, but we have some kind of short somewhere. Just going to check everything again, I guess, and see if we can find something.
One eternity later.
Okay, I think I figured it out. I just made the assumption that these jumpers would connect this way, but I think they are supposed to connect this way. So I cut these now, and we no longer have short. This caused the caps key to permanently be activated, I think. So we're going to have to remove these wires and put some other wires in these positions to have the modern keyboard layout. I apologize. That was probably not the wisest move to assume that. But there's these lines here that kind of indicate you need a connection from there to there. And there's only brackets for the connections between these two. Yeah, we need to close the jumpers the other way around. Horizontally, not vertically, I think. And then we have a working keyboard, probably.
5 minutes later.
Yep. That was exactly what the problem was. Now it appears to work fine. It all seems to work now. That's the other shift, spacebar. Yeah, that's working now perfectly. So yeah, that was just me. The keyboard works fine. So I guess it's time to put the keycaps on. Okay, actually the instructions say that this should be closed from the middle position to the right position. Middle to right. I closed them from the backside of the board now with a lag from a resistor just soldered across them. So that should now be correctly set up. Now for the special keys, of course, these have an odd shape. And you can use these adapters here to use the original keycaps. There's different versions of the original keycaps. So this is the side that plugs into these switches here, and the other side plugs into the different shapes that there are for the original keycaps. You can also use 3D printed parts like these. It is recommended to paint them so they match better. I quite like these actually. And these should just plug in. Yeah, works beautifully. These need to be made with a proper 3D printer, like a resin printer, because they require quite some precision, but then they actually fit fine. So yeah, these are our special keys, new 3D printed versions of those. And I think to match these, I'm going to use the dark gray keycaps that were provided. Also have a set of white ones here, and you can have beige ones as well from WASD, but I think these are going to match the best. And if I don't like them, I can still use the original keys on there as well. Yeah, and the final step should be putting all these keycaps on there, which are custom printed to have like Atari special keys. And I think there are some extra keys in here with little Pac-Man ghosts, things like that, which are of course pretty neat if you like such things. And you can also configure this with more key switches to use it as a keyboard for an emulator or something like that. There's also a bunch of empty keycaps here that you can customize to your liking. But these should just plug in, so it's not a big deal. These should fit perfectly on these, yeah. That works beautifully. So the keys are labeled, so I know pretty much which keys go where. Just going to find them. And these are the special keys included. The ghosts and Pac-Man. So you can use these for the Atari key, for example. And these are nicely packaged in rows. Okay, this looks very magnificent. And it feels like a proper keyboard, just as I had hoped. There are a couple of options for the break key and the Atari key here, which I'm going to show you. So here's the options. We can have a red break key, which I kind of like. And we can have a Ghost or a Pac-Man or one of these for the Atari key. That's pretty neat. And of course, some of the keys are a bit swapped around compared to the original. But yeah, we have caps here where there's control on the original keyboard, and we have delete and backspace here as one larger key on the new keyboard, and have break here and control here next to the spacebar, where it kind of makes more sense. We have a larger return key, so no more hitting caps when I want to push return. For me at least, this makes complete sense, but I'm not used to the original Atari keyboards because I was a Commodore user and the keyboard layout is slightly different, obviously. Very nice. One other thing, these original keycaps of course have the graphical symbols printed on the side of the key here on the front, whereas these have them printed on top, because it is a very, very expensive process to print them on the side of the keys or on the front, and that's probably not really done by any keyboard manufacturer these days really as a process, unless you have like really large volumes. This, like all WASD keycap sets, comes with a nice keycap puller again, which I have quite a few of now. I think I want another Atari logo there, maybe. So I'm just going to pull this and put the... I'm not sure, maybe this one, or... I want the small Atari logo there. I think that looks the most elegant. The colored break key, I'm not sure. No, I like it this way. This looks really sober. So let's put it all together and see how it looks in the machine actually. It should have quite a nice Atari Falcon-like appearance. Except that my AtariXE has a pretty yellowed case. It didn't do anything with that yet because I wanted to get the memory expansion to work, which I still didn't get to work after I think 3 videos that I made about that. Probably giving up on that at some point. But this is about appearance, and my Atari still works as the 65XE that it is, at least. So we can put it together and see how this looks in an actual Atari. I warned you about this Atari. The shielding is super rusty and yeah, it doesn't look great, but this is hopefully going to do. So this sits on here. So we can put some spacers in here. I think these are supposed to sit here, which also are 3D printed parts. They fit perfectly. And then we can close this up. Ooh! Apart from this being super yellow, this looks really nice. Wow, this feels like a completely new computer. Like a different computer than what it was. That's pretty neat. And the white LED actually becomes red because there's a red inlay in the keyboard assembly here. Yeah, and I didn't put the screws in because honestly, I forgot where I put them. But I'm going to find replacements for those. That's why it's shaking a bit. But it fits really nicely in this machine. Can close it all the way. Looks magnificent. It's going to look even better with an Atari that actually looks better than mine. So let's see what it looks like with the backlight. You can barely see it because my video lights are so bright. I'm just going to turn down the light a bit. That's the backlit Atari. And the changing colors you can see in the background are from the screensaver on my Macintosh that's running in the background here. This is what it looks like. Pretty neat. Looks really cool. Yeah, and you can set the brightness of the backlight with a little potentiometer on the board as well, if you so desire. Yeah, I think that's it for today. Looks magnificent. And it feels much nicer to type on. I'm going to have to do some work on the case and probably ditch the 320k RAM expansion that I wanted to put in this. But other than that, this keyboard replacement works beautifully. Even with some little mistakes that I made, I got this to work. So that's nice. That's it for today. Not much more I can say about this. It works beautifully. It looks very nice work from everybody who was involved. And to Bertrand and Jesse, thanks for giving me the opportunity of checking one of these out. The other one that I got is actually going to be a giveaway on my supporter pages, Patreon, Ko-fi, and the YouTube channel memberships page. I'm going to make a little video where I give that away on those channels. If you are not a supporter, thank you for watching and thank you for your subscriptions and your thumbs and your comments. If you are a supporter, thank you even more for your support. And thanks everybody for your time and watching my videos. Hope this was informative and entertaining. Hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye.